Hello everyone. Today we're going to do the type 2 models and type 3 models of functions where we are asked to find domain and range. I've already made 2 videos in this. The first two videos was on type 1 models, which was all rational functions. And here we are going to do type 2 and type 3. As you can see in the screen, type 2 are square root functions, type 3 are modulus functions. Alright, so here we're going to find the domain and range for root functions and for modulus functions. So let's get started. Type 2, first question. As you can see in the screen, root over x minus 1. So first one, find the domain and range of root over x minus 1. So that is nothing but y is equal to, isn't it? Y is equal to root over x minus 1. Now what is the domain of this? Domain is all the values that I can substitute in the place of x. Now root of x minus 1, root of x minus 1 must be greater than or equal to 0, isn't it? Therefore, the domain value will be x greater than equal to 1, right? So domain will be 1 to infinity. Domain of the function is 1 to infinity here. Now range. Since y is the range value and y represent root over x minus 1, when root over x minus 1 is greater than equal to 0, it means y is greater than equal to 0. That means y value will start from 0 and then above. So range will be 0 to infinity, open bracket. Alright. So domain will be 1 to infinity, close bracket 1 to infinity. Range will be close bracket 0 to infinity. Now let's take the next question. The B question. What is B question? 1 by root over x minus 5 minus x. 1 by root over 5 minus x. One by root over 5 minus x. Now, domain of this. Domain of this will be all the values that I can admit in the place of x. And that does not make my denominator 0, as well as the value inside the root must not be 0. So that means root over 5 minus x must be greater than 0 here. Please note the point. Please note this and this. What is the difference? Here we write greater than equal to 0, whereas here we write just greater than 0. Because here I cannot accept 0 in the denominator. I can accept 0 in the numerator. Whereas here I cannot accept 0 in the denominator. Here the root function is the numerator. So I can accept 0 in the numerator. So I can have a number in the place of x where that result in root of 0. Where here I cannot accept any number in the place of x that result in root of 0 in the denominator. So root over 5 minus x is greater than 0, not greater than equal to 0. Understood? Now that means 5 minus, that means root over 5 minus x is greater than 0, 5 minus x greater than 0, 5 is greater than x, or x is less than 5, isn't it? So therefore the domain value of this will be minus infinity to 5. I don't include 5 here. So this is the domain of the function. Now the range of this function. Alright, well, what is the range? Range is the y value. Now root over 5 minus x if it's greater than 0, then 1 by root over, let's make some space for this, 1 by root over 5 minus x is also greater than 0, which means y is greater than 0, isn't it? So that means my y value, that is the range value, should start from 0 till infinity. So this is the range of f. Alright, so we did the first question, we did the second question. Now we are moving to the third question. Please see the level of the question. The first question was root without any square. The second was 1 by root without any square. The third one was root with x square. Now fourth one is 1 by root with x square. Alright, so each question is each type here. Third question, root over x square minus 4. Let me check once again. Yeah, root over x square minus 4. Now, how do we do this? Domain of the function. Domain must be the values that result in the root positive. So, x square minus this should be greater than or equal to 0. So, that means x square minus 4 is greater than or equal to 0. Isn't it? So, I get x plus 2 into x minus 2 greater than or equal to 0. So, that means the product of these two should result into an answer that must be positive or 0. Now, which value should I admit for x here? Better we do the number line for this. Alright, let's draw the number line. Minus infinity to infinity. Critical point is minus 2 and 2. Now take arbitrary values for x. Let's assume x lies here first. Let x be any value between minus infinity to minus 2. Say you go for minus 3. If you take minus 3, what do you get? You get minus 3 plus 2 into minus 3 minus 2. So this is negative into this is negative. So the result is positive, isn't it? So here I get a positive answer. Then obviously even here I get a positive answer and over here I get a negative answer. Here we get a negative answer. So here we get positive, here we get positive, and here we get negative. So x must be between minus infinity to minus 2, union 2 to infinity. Now should I include 2? Yes, I can include 2 and minus 2 because that can only make root 0, which is 0. So domain of the function here is minus infinity to minus 2, closed bracket, union 2 to infinity. Alright, now let's do the range. Range of the function. Now, root over x square minus 4 is greater than or equal to 0, isn't it? So that means y is greater than or equal to 0, right? Because y represents, this is nothing but y. So that means the range would be 0 to infinity. Clear? Let's go to the next question. The D question. 1 by root over 9 minus x square. 9 minus, to find the domain again, 9 minus x square should be greater than 0, not equal to, because if I get 0, denominator will fall out to be 0, which I don't want. So it's greater than 0. Alright, so 3 plus x into 3 minus x. greater than 0. Now use the number line minus infinity to infinity, and we get minus 3 and 3. Pick out random values for x. Say x is between this interval and between the next interval. So when you fix values, you will come to know between these two intervals it's negative, and between this interval it's positive. When you take random values for x between these intervals and apply it over here, you will get to know that between minus 3 to 3 it is positive. So domain of the function, domain must be minus 3 to 3. Open brackets, because if I include 3 or minus 3, the denominator becomes 0. That means it results into a y value which is undefined. So we will not include 3 or minus 3. Now let's do the range of this. Range of the function. Alright, now listen very carefully. Range are the y values. As the square root is always non-negative, as the square root of anything is always non-negative, that's y greater than 0. So y equals 1 by root over 9 minus x square. Y square equals 1 by 9 minus x square. 9 minus 1 by y square equals x square, right? So you get 9y square minus 1 by y square equals to x square. So we get x equals root over 9y square minus 1 by y square, which is nothing but root over 9y square minus 1 by y, isn't it? Now what are the critical points that we get? Plus or minus 1 by 3 and 0, isn't it? So let's draw a number line. Minus infinity to infinity. Minus 1 by 3, 0, and then 1 by 3. Now take random values in these intervals as your y. Now which means take y here, take y here, take y here, and then take y here. When you take random values between these intervals as your y, you will come to know that between minus infinity to minus half and 1 by 3 to infinity, it is positive. You will come to know that between minus infinity to minus 1 by 3 and 1 by 3 to infinity, it is positive. So the answer is minus infinity comma 1 by 3, 1 by 3 union 1 by 3 comma infinity. Now should I include 1 by 3? Should I include 1 by 3? Yes. There is no harm in including 1 by 3 or minus 1 by 3 because it hardly makes the numerator 0. That's all fine. If I consider y as 1 by 3 or minus 3, only numerator becomes 0 and root of 0 is 0. So the bracket must be this bracket. So now I'm saying that y should belongs to this set. I said that y should belongs to this one. Minus infinity to minus 1 by 3 union 1 by 3 to infinity, which means I'm excluding a particular value 0 here. Hope you must have watched my first two videos properly. Before we exclude a number, we have to be very sure whether there is no x value giving that particular y value which we are planning to exclude. All right. Also, whether this particular the y that we assessed is actually the answers of the x or not. Chalo, let's see now. Now, what is y? Y are the answers of x. When I substitute x in the function is, what is the function? The function is y equals to 1 by root over 9 minus x square, isn't it? So x are the domain values, y are the range values. So x lies between this. When x lies between this, I've taken care that my y answers are always positive because of this. Because I substitute x value, that makes this particular number positive. Right? So, since y is greater than 0, we already made a point of it. Since y is greater than 0, the y that we discussed here, or the y answer that we got in the previous step, is not the exact range. The range of this function is just 1 by 3 comma infinity. So leaving 0 is absolutely fine because y is greater than 0. So I can exclude 0. So that's fine. Now among this, y can't be this because y is greater than 0. You understand? Y is greater than 0. Therefore, the answer should be 1 by 3 to infinity. This always happens if the question is in the form of 1 by root over a square minus x square type. Alright? Okay, let's do the next sum. As of now, we have completed the model 2, the type 2 sums. Alright? Now, we are heading into type 3 models. Type 3 are all modulus questions. As you can see, the first one is mod of x. So, or otherwise, let's assume it as y is equal to mod of x. Now, what is the domain here? Domain for a modulus function, all real number. There is no need for any discussion, isn't it? X can take any real values. What is the range here? Well, x can take any real values, but y are only positive real values. Yes or no? Y will always be positive real values. So therefore, the range is 0 till infinity. Oh, understood? Now, the next question. Y is equal to minus of mod x. Simple again. Domain, there is no scope for any doubt. Domain is all real number. Now, what is the range here? Mod x ranges 0 to minus infinity, 0 to infinity. So, when it is minus mod x will give me always positive answer. But it's minus mod x, so y will always be negative. So, it is minus infinity. It's minus infinity, comma 0. Clear? Everyone? Now, let's go to the C question. C. C is 1 minus mod of x minus 2. Right? C is equals 1 minus mod of x minus 2. Now, what is mod of x minus 2? I mean, what is the domain here? Domain is always any real numbers. Domain is always real number for modulus functions until it has something in the denominator. If it's a combination of 2, 3 functions, then if it has something in the denominator, then make sure that you eliminate that particular x value which makes the denominator 0. Otherwise, also if it's a root in the denominator, you eliminate that value that result in root negative. Otherwise, modulus will always have a domain which is all real numbers. Now let's do the range. Mod of x minus 2 is greater than or equal to 0, isn't it? Modulus values are 0 because we just now discussed what is range of modulus x. So modulus of x minus 2 value will also be always 0 or above 0, right? But here we have minus mod. So I'm multiplying the inequality both sides by minus. So minus mod of x minus 2 greater than equal to lesser than equal to 0, because when you multiply minus on both sides the inequality will reverse, isn't it? Now I'm going to add 1 because I want exactly this. I'm going to add 1 on both sides. So 1 minus mod of x minus 2 is less than equal to 0 plus 1, which means I'm getting 1 minus mod of x minus 2 lesser than equal to 1, which means y is lesser than equal to 1. And what is y? Y are the range values. So that means the range of the function here is minus infinity till 1 including 1. Clear? Alright, let's go to the next question. D question. We finished the first 3 sums of model 3. Now the fourth one. Y is equal to mod of x plus 2. Y is equal to x plus 2 by mod of x plus 2. Alright, now domain. Domain of the function is all values other than the one that makes the denominator 0. So here denominator becomes 0 when x is minus 2, isn't it? So domain will be all real values except minus 2. Now range of this function. How to find the range of this now? Well, how do we expand modulus function? Y is equals f of x, isn't it? Equals x plus 2 by minus of x plus 2 when x is less than minus 2, and x plus 2 by x plus 2 when x is greater than or equal to minus 2 of x equals x plus 2 by minus x plus 2 because it's mod of x plus 2. So when you take a value lesser than minus 2, the function will be minus of x plus 2. When you take a value greater than or equal to minus 2, the function will be x plus 2. Alright, so that's how we split mod, isn't it? Eventually, this gets simplified to minus 1 when x is less than minus 2 and 1 when x is greater than or equal to minus 2, right? So it's minus 1 and 1. So these two are the range values here. So range of this is minus 1 comma 1. This is D. Now let's go to the next question. So we finished the D1. Let's go to the E1. E is y equals mod of x minus 3, isn't it? This is just like the first two sums. Very simple. Domain is all real number. Range will be all values 0 and above. So 0 to infinity. Simple, isn't it? Next question. Next one, it's 3 minus mod of x minus 2, which is similar to this one, is similar to C type. So I'm going to do exactly like I did the C1. F. Three minus mod of x minus 2. 3 minus mod of x minus 2. Now, what is the domain here? Domain, all real numbers. What is the range here? Mod of x minus 2 is greater than or equal to 0. So minus mod of x minus 2 is lesser than or equal to 0. Why minus? Because there is a minus here. Now I am going to add 3 on both sides. So I get 3 minus mod of x minus 2 less than equal to 0 plus 3. So that means I am getting y less than equal to 3. What is y? The range value, isn't it? So the range of this function is minus infinity till 3 including 3. Clear? Guys, we did till f. Now we are moving into f sum. F is over. We are moving into G sum. G sum is somewhat similar to D sum. D and G are similar sums. F and C are similar sums. So you can find the way we are solving the exact way you can do all the similar kind of sums. So mod of x minus 4 by x minus 4. Y equals mod of x minus 4 mod of x minus 4 by x minus 4. Alright. Now, what is the domain here? Domain will be all real values except 4. Right? So, domain of the function is all real value except 4. Now, what is the range of the function? For that, I'll split the function. Y equals f of x equals minus of x minus 4 by x minus 4 when x is less than 4, and x minus 4 by x minus 4 when x is greater than or equal to 4. So this will further reduce this to minus 1 when x is less than 4 and 1 when x is greater than or equal to 4. So that means, tell me what y is. Y is minus 1 and 1. So y equals minus 1 comma 1. So that means the range of the function is minus 1 comma 1. Clear? Now the last question. The last question is y equals mod x minus x by 2x. Mod x minus x by 2x. What is the domain of this? All real number except 0. Because if I put x as 0, denominator will become 0, y will become undefined. So domain will be all real numbers except 0. What is the range? Range, for that I have to simplify, isn't it? Y equals f of x equals minus x, right? Minus x by 2x when x is less than 0. Why minus x? Because it's mod x. Mod x we split it as minus x when x is less than 0 and x when x is greater than 0 or equal to. So when I go for lesser than 0, mod x will become minus x. The remaining term will remain as it is. And when I go for x greater than or equal to 0, mod x is considered as x and minus x by 2x as it is. This will eventually reduces to minus 2x by 2x when x is less than 0 and 0 by 2x when x is greater than or equal to 0. Isn't it? So now what is y here? Y equals minus 1 when x is below 0 and 0 when x is greater than equal to 0. And what y represent? Y represents the range. So range is minus 1 comma 0. That's it, guys. I explained type 1, type 2 and type 3 sums of domain rules. Now we have one more type, which is trigonometric models. Hope you hope you understand this. Please work out more sums on this type to make yourself clear with the concept. If there is any doubt, you can put it in the comment box. Thank you.